Good morning and welcome to West Texas A&M University. This is an important seminar and the topic is climate change, environment, and marketing. Almost every day we read about this topic. I mean, if you look at Wall Street Journal, today's Wall Street Journal, if you look at Financial Times yesterday, they have news items and they are talking about. So, what it has to do with marketing? A lot. And you watch TV, you read in the newspapers, you look at your textbooks, you go to your classes, we buy things, we consume things. We are all impacted by climate change, but we have to be familiar. There are many schools of thought. You have pros and cons. The life is not simple. You have pros and cons. Some people like it, some people may not like it, but we have to use logic. We have to use data. And we have to convince people as an educator. And so that is our job at WT and other places. So, what are the topics we are looking at? And those topics are very, very diverse. For example, anthropogenic. These are the activities directly or indirectly caused by human beings. And then we have other topics. Circular economy is already $100 billion. When people buy fashionable clothes, used, recycled, this is part of climate change. And then you pay attention to your electricity. Then you have your consumption pattern. So how big the market is. And in our classes, since this is a principles of marketing class, the global consumer market is $44 trillion. Very big. And so climate change plays a very important role. So for this reason, I have two distinguished speakers. These are my colleagues. And they will be talking about, they will help us understand the issues, the realities, and what are the misconceptions. And that's our job. But what are the other topics? Recycling, carbon credits, collective action, global cooperation, weather patterns, melting of glaciers, climate finance, climate funds, geopolitics. I mean, it can go forever. We can have a whole day seminar on this topic. But anyway, these are my basic comments. And every day, when you buy things, you are part of the global economy. Economies are connected, we are connected, markets are connected, industries are connected. 55% people in the US, they have iPhone. And you are connected. So we are aware what's happening in front of us. The world has changed big time. So without further ado, I'm going to invite our first speaker, Dr. Erik Crosman. Let's give a warm welcome to him.
Thank you, Dr. Anwar. Thank you very much. Thank you very much for inviting me today. It's an honor. It's a great honor. So I'm going to go first for 22 minutes or so, and then my colleague, Dr. Rogers, will go next. So I'm an assistant professor of environmental science. I'm going up for tenure this May, so hopefully become an associate professor of environmental science starting in May. I started WT in August of 2019, and I teach oceanography, maybe a class that and a lot of environmental science class and environmental science majors take. And so it's a great honor. It was an excellent introduction. And so what we're going to try to walk you through, and again, we could spend days on these topics, but background on climate change, the science of climate change, and then connecting that to business and marketing to some degree at the end of the conversation, and also intertwining that with adaptation and mitigation, forward-looking, right? Because as for this to be relevant, I think it's really important, and you're the next generation for forward thinking of how we move with climate change. So I always have this discussion with my students in my environmental science classes and others as far as climate. Climate's been changing forever, millions and millions of years. It's always been changing, and so there's certainly many of my students, their school of thoughts that that's where it ends. They're not sold on the anthropogenic climate change. They're just on the climate's been changing naturally. And both are right, in my opinion. So examples of climate change in the past. So the Vikings, during a very warm period, around 1,000 or so years ago, colonized Greenland. Then there was a cold period. So this is temperature. Then there was a cold period where it iced over, basically, and the Viking settlement was lost. This was before the anthropogenic climate change that we talk about now. These were natural cycles, so there's many natural phenomena that affect climate. So volcanoes spew ash, and the ash acts like a layer that blocks the sunlight. Sunspot activity, the more sunspots there are, the more radiation comes in from the sun. And so these are often things that are attributed when people say of making the case for natural climate change, and they're true, but they're only part of the story. What I'm going to focus on is this rapid recent change that we've had. The issue that mankind is facing today is that our rate of change, so we've taken deposits of coal, natural gas, oil, right, deeply buried under the ground. We've brought them up and burning them through fossil fuels, and they go into greenhouse gases through our combustion processes. So carbon dioxide is the largest one, methane, nitrous oxide, also from combustion, and then a bunch of other trace ones. Trace chemicals that we put up in the atmosphere. They're a very small fraction. They really are trace amounts, but as we'll see, they're critical for changing the energy budget of the planet. And this has never happened in the history of the planet where we have increased these gases this rapidly into the atmosphere. So the rate at which the change is happening faster than it's ever happened before. 3 million years ago, we were warmer than we were now. The sea level was 20 to 80 feet higher. Most of the cities we know would have been underwater 3 million years ago. They didn't exist yet. Civilization didn't exist, but the rate at which those changes happened were much slower. It's like changing the gears too fast. We're changing it so fast that we're looking at massive impacts. So a way to illustrate this, you see here, this is carbon dioxide. That's one of those emissions of us burning fossil fuel, the carbon dioxide gas. See it going for the last million years here about, up and down, all below this 300 parts per million level. And so these sort of changes, the ecosystems could adapt to, and just the face of the planet was changing. Albuquerque used to have, dinosaurs and fir forests and be tropical. So these, the Earth has been, the planets have been moving. Everything has been changing over time. What we had happen here around 120 years ago is Industrial Revolution, industrialization, the rapid, and this is continuing in third world countries to this day. We're shooting up. Our rate of increase is just going skyward really fast. Here's another way of visualizing it. This is the carbon dioxide. China and the United States have been the biggest contributors, followed by Asia, Middle East, India. Europe's population has decreased, so it's leveling off, whereas China and the United States continues to rise. These are the emissions. The key factor here is that these carbon dioxide levels, these gases that we're taking from buried in the earth and into the air through our burning of fossil fuels, they have lifetimes of hundreds of years. So everything we do, everything our grandparents did, it's going to hang around for a while and affect the climate until hundreds of years it can be processed through natural processes, because it can uptake that and vary. But we're injecting huge amounts, and it takes hundreds of years for the nature to process or take care of those. And so there's a lag. Even if we were to stay the same or not increase our carbon emissions or keep them steady, we're still increasing the amounts because they stay in the air for such a long time. So how does this all fit together? Those greenhouse gases that we've been putting into the atmosphere through burning all the fossil fuel, they act like a blanket to the Earth. So the sun, the radiation from the sun varies by 1% based on sunspots. Sometimes it's a little higher. We can't control that. But we are controlling the thickness of this blanket, and we're putting on a down coat, essentially, by adding the amount of these greenhouse gases. So the sun's energy comes in, it's absorbed by the Earth, and then it's re-radiated out as infrared radiation. And the gases trap it from leaving to space. So we can't cool ourselves as effectively as we used to. This effect is critical for life. We would have no agriculture. We'd have nothing going on. It'd be 60 degrees colder. We'd be an ice planet if we didn't have it. So it's a good thing, but it's too much of a good thing when we rapidly increase the CO2 levels like we're doing now. Again, they've been higher than this in the distant past, but the rate at which they change was slower. We're changing the gears so quickly that it's very disruptive to the Earth's ecosystem, animals, plants, and life. And the science is, the the exact outcomes of climate change is very uncertain. That's where a lot of the back and forth, whether people believe or don't believe into it, come from. But the basic relationship between the amount of these blanket greenhouse gases and temperature is very clear, regardless of what data sets you look at across multiple tons and tons of scientific data. It's a very clear relationship that as you increase this carbon dioxide, it does make a warmer planet. And we've seen that for millions of years, going back with natural cycles. There's lots of records. So it's really indisputable that that relationship exists. Impacts on the planet. Okay, I'm not gonna belabor this in the interest of time too much, but massive disruptions, right? Mass extinction, massive changes to sea level, with the oceans, the ice melting and rising the ocean level. These are things that have happened in the past, but again, not this quickly. And again, we've built all these cities along the coastline. So if the oceans rise 10 or 20 feet, it's going to be a huge infrastructure impact. For all of the ecosystems, if they change more slowly, they evolved, species distribution moved, the animals evolved. Now it's so fast that we're looking at a mass extinction event, most likely. And it's already starting, is what the data shows. Okay, I'm not going to talk too much. I think we as humans, we may have wars, it may be difficult for us, but we're very adaptable. So we will survive, and it's up to us to kind of figure out how we help the animals survive through this period and to mitigate how rapid those changes are in the future, because it's just starting. So in terms of coming back to Texas, impacts on Texas. So the main impacts in Texas are all of your extreme weather events go up. So I'll try to describe what happens with a warmer planet. Remember, we talked about the greenhouse gases causing more heat. With more heat, you have more energy. With more heat, you can also hold more moisture. So think of like taking a really hot shower or whatever and steaming up a sauna or something. It holds more moisture than a cold room. And so by warming our atmosphere, it can hold more moisture, which gives us more fuel for hurricanes, tornadoes, etc. The greater heat it results in more drying and droughts during those periods when we don't get moisture. And so there's all the extremes increase. And so in Texas, extreme heat waves are going to increase. When it doesn't rain, the soil dries out faster. When the soil's dried out, then you don't have moisture to convect for thunderstorms. So then it propagates. It's a feedback mechanism. If there's no moisture in the ground, there's no moisture for thunderstorms. And so droughts are predicted to increase. And these are many climate model simulations that, like the forecasts for every day that you get in your weather, they're not perfect, but they're pretty good, and they run them out for decades. And they see what the future in these models brings, and that's how they come up with these outlooks. So more drought, and we've already seen, many of these climate change impacts are happening in the last few decades. So Texas drought of 2011, okay, your parents, ask your parents about this. Very, very bad. Many of the Texas cattle had to be sold off because the grass was too expensive. There were terrible wildfires, which actually killed a lot of cattle as they blew through. I remember hearing thousands of cattle were burned to death. Many crops failed, about half the crops. So it was a greater than $10 billion disaster. Now, this era, that's not really, we're having billion-dollar weather disasters all the time. But it stood out in Texas at that time, and we had another one in 2021 that wasn't quite as bad. And it looks like these will become more frequent with climate change. So the bottom line is we have, by increasing very quickly these protective gases in the atmosphere, we have this shift towards a lot more heat storage, which can increase the possibility of all these other things happening. And that's the reality. That's our best scientific understanding of the situation. The details of how things evolve in the future are uncertain. But the models show that in like 50 years, Texas is going to be more like Phoenix, Amarillo will be more like Phoenix, and Oklahoma or Iowa and Illinois will be more like Amarillo. Just the climate will shift. The breadbasket will shift into Canada, and the breadbasket now will become more like Amarillo. So that's based on kind of the medium projections of what happens. So our heat waves will increase. we're looking at, in a worst case scenario, we're looking at like 115 degrees in the summer every day in Amarillo with 125 degrees on the hot days, right? So that we're getting to a point where that becomes difficult for a cattle industry, difficult for crops to survive. So we are certainly in one of those areas where it is scary, it is threatening. I did a study with students, and I'm just going to blast through this so that I have time to talk about mitigation and others. So but the students, you've all been hiking in Palo Duro, right? You've all visited Palo Duro. It's even hotter down in that canyon. So we were doing a study on why that is and how to forecast that. But you could almost, Palo Duro is almost going to be like what Amarillo is going to be in a decade. When you go down there and it's hotter, shift that climate up here, and then the canyon will be even hotter. So what happens down there is, and I put weather stations, my WT students hiked around. Okay, I almost passed out from heat exhaustion after almost getting bitten by a rattlesnake, and I was joking that would make the Darwin Award, that a professor who's studying extreme heat dies of extreme heat, right? But it was rewarding for the students. They launched weather balloons. They drove around. Here's pictures of them all over the canyon, installing these, they're low cost, but these little sensors, we had to put little covers on them so the sun doesn't impact the measurements. Here's a bunch of them standing. And so I'm not going to go into the details, but essentially it's like an oven. The canyon is like an oven. The rocks and the sides absorb some of the heat that goes off the rock, and all the rocks themselves hold heat. And so it's like an oven, and we are basically determining the situations that the oven is the worst, so that the Weather Service in Amarillo knew the days that were going to be like 15 degrees hotter than Amarillo versus the days that weren't. So there's certain conditions where the oven is more pronounced in the canyon than other situations. Another thing that we'll have to worry about in Texas is extreme floods increasing. Remember, I talked about with the increased heat means increased ability to evaporate moisture into that atmosphere. And when a front comes along or you rise that air and it condenses, you hold more moisture. It's like a sponge. You have more of a sponge to squeeze out. And if it happens to come down, your grandparents may remember, or your parents when they were little, the Palo Duro Canyon, the floods around the late 70s. Dr. Cepeda, one of the geology professors here, wrote a paper and has the high water mark, if you see that down there along one of the bridges, for that flood where it was really, really deep in the canyon. The one the last few years ago was pretty bad, but nothing like the one in the late 70s. And we've seen this play out. Texas had a third of the nation's, or a huge fraction of the nation's floods in 2023. Some of you remember some flooding around in that summer. We had massive rains. So we're seeing these, what the climate models predict of, more intense storms, more frequent floods, more intense droughts, everything kind of being amped up. We're seeing that happen. But it's just, if we continue on our trajectory of adding more and more of the gases, there's no reason, it's logical that we're going to ramp those up even more. It's going to baseline will get hotter, the droughts will get worse, the extreme rain events will get worse. So where we go from here is up to us, and so the remaining minutes I'm going to talk about adaptation and mitigation. So this is you'll see lots of these kind of plots of scenarios, and no one really knows. I was just looking at some recent studies where they're saying all of these have baked in too high of population, because we're actually not, the population is not increasing right now going forward as it was predicted. They were thinking it was going to 10 or 20 years ago. So that could be good news for not going as high, having quite as strong of emissions. That said, much of the world, third world countries, they're all moving to, everyone wants to get a car, everyone wants to have air conditioning, they want to have the quality of life that we have. That's very carbon intensive, that's very energy intensive, and if we're burning coal and drilling for oil and all these things, it will continue to put those gases into the atmosphere, unless we move to clean energy or another source of getting that energy. So basically, business as usual is in the kind of high or very high. If we start to cut back on our fossil fuel use, then we can go into some of these more low cases. All right, I'm not going to go into the details. I don't think anyone really knows. I heard many experts saying different things. Some are very negative and just say, enjoy the train wreck. And others, like we had an engineering professor here from Rice at WT, and he said he feels like the solar industry is already up and coming. It's going to take care of everything, all these new technologies. So there's experts on all sides of the spectrum. I think the consensus would be it's still a major concern going forward. The trajectory that the Earth is on right now, we're going to see significant warming that's going to have significant impacts, and we're just going to have to adapt. So let's now spend the last 5 minutes here talking about adaptation and mitigation. So sea level rise, again, if the predictions are all over the place, but what I hear anywhere from 5 to 20 feet of sea level rise coming in the coming 50 to 100 years, and that would be 20 feet of sea level rise along, that would affect like 10 to 20% of the world's population. That would be huge, right? Because where are those people going to go? All those people that live in apartments right along the coast? It's like having a hurricane that covers every city in the world with 20 feet of water at all the coastal areas. It'd be devastating. So how do we, and you all as marketers motivate people to make changes, motivate them on what's coming up here, if that is actually ends up being the trajectory we're going towards. They talk about wars coming out of limited resources, all of these things, and I don't think anyone really knows, but water will become more difficult to come by with high evaporation. We're already stretching a lot of these resources thin, so it's that we would have shortages of water with the hotter Earth with higher evaporation. Makes, it seems like a likely scenario. Okay, wildfires, hurricanes, we're already seeing areas that are at risk of being uninsurable, parts of Florida, the California wildfires we just saw. We've always had disasters, but the frequency, I don't think anyone can argue that the frequency of these and the expense to society and the impacts on business, marketing, is increasing, and we're going to have to look at it. So how are we going to become resilient in this situation? So I like this slide that I found that had two main circles, that our resilience will depend on both mitigation and adaptation. So we have to do what we can to blunt the situation so that the future impacts aren't on the extreme side, right? I think it's unrealistic to think that we're going to just not have any. So that's why the adaptation comes into play. Right? If we're in an area like California, figure out what's wildfire risk. Don't build in wildfire risk areas, or make sure all the brush is cleared out, these sort of things. And we'll talk about, there's all sorts of engineering type things that can be done to mitigate both globally and locally. So adapting to what's at hand, looking further ahead and saying, okay, this is what's likely to happen. Let's change for that, and then doing what you can. With like public transit's not really feasible in the Panhandle, right? And agriculture needs their trucks, right? But if you get a truck that's a hybrid or these sort of things, potentially, then you're doing your part to mitigate how much of those gases we're getting into the atmosphere. So what are some ideas for how to, I don't want to be gloom and doom. Your generation is going to be critical, and I think it's really important to go into it with, I think you can make a difference. We can come through this, we can adapt, not, because when I was in college, it was just all gloom and doom. And now we're not even talking about it as much these days. But it was just lots of gloom and doom. It made me very depressed. So there's a lot of discussion about geoengineering. So giant disks in space that block the sunlight. Remember how the volcanoes will naturally block some sunlight? So actually putting something in space to physically block some of the sun, that would work. It's just, that's a huge engineering feat. It's been talked about. I don't know how close we are to getting something that would be fundable on that. And then all these other approaches in the atmosphere, changing the clouds, all have a similar effect of changing the energy balance so that we are able to cool the planet. So there are ideas out there, and you'll probably hear about them more. Once society is completely on board with that action needs to be taken here, I think then you'll quickly hear all of these sort of things come to the forefront, and there'll be some action taken. and large amounts of funds put into trying them. Okay, Dr. Rogers here is going to be talking a little bit about ag, and the idea of carbon sequestration is illustrated here, right? Let's just directly, like we said, we put that gas in the atmosphere at a record rate. Let's just take it out, right? It's challenging, it's expensive, but he's going to talk about incentivizing that for the ag industry. That could bring money into the local ag industry and also be part of the mitigation, part of the solution here. Lots of other ideas. This is a little far-fetched to me, to wrap our glaciers in some sort of white blanket to reflect the sun's energy, but certainly making builders have roofs that are white. White reflects energy. If we just made that all the roof material is white, that would automatically change the urban heat balance and would act very much as cooling compared to like having asphalt, tar, these sort of things. So there are many ideas. You can fertilize, those that took my oceanography class, you can fertilize, spur algae growth, and that algae growth uptakes the carbon and then takes it to the bottom of the ocean. It's basically putting a natural process and supercharging it. So there are many ways to take it down, but we have yet to have a sustained, effective solution globally where there's something going on. There's lots of ideas, lots of proof of concept, but nothing's happening right now. That chart is just shooting up like what you want to see your stock market going, but unfortunately it's the greenhouse gases. And so we'll have to look at that. I'm short on time here, so I'm going to skip to this one and just say and Dr. Anwar, correct me but from my read of looking around, that just similar, it's the same way in the sciences or in society in general. There's still vast majority of the companies and corporate world that has a ways to go in terms of engaging on 20% have an adaptation plan for climate change, right? We need to adapt. And so again, your generation, you're going to be increasing these numbers, right? And I have no doubt about that. Most of them have no idea what the costs will be. So I like this list of some of the 10 tips, and I think the number one I just point out really quick here, don't wait, right? There's a sense, the fundamental issue with climate is that it's so large and so complex and impacts so many parties, right? And I'm not saying we need to change our lifestyle. In Europe, there's a whole movement to not fly because it's cool, because then you show that you're saving the planet by not using carbon by flying. I think everyone should live their lives how they want to, but we need to be more proactive in terms of let's not just wait and see what happens. Let's get out ahead of this and make some proactive. So mitigation strategies for business, for marketing, right? Not waiting, thinking a longer timeline. I don't usually think more than a week ahead. I think my students think about an hour ahead. Okay, I'm not making less of you. I know your lives are right. That's how our society has. We're just chasing the next thing that we have to do, right? But we need to start thinking longer ahead. We need to start thinking of a plan for what can we do ahead of time. And this will benefit if it really happens like this. The businesses that will come out ahead will be the ones that think ahead. And I have a friend that works for Amazon, and their Amazon Weather. They're looking at these things. They're thinking about how do they sell those white roofs? How do they do the things ahead that are going to be needed, and position themselves so that the moment the societal consciousness says we're all getting white roofs, they're the ones selling the white roofs. So it's making those strategic plans ahead of time to be part of the solution, to help adapt, as well as to make money, to be in the right place at the right time when these things are needed.
Okay, well, thank you for having us. I'm kind of a little bit odd professor here in that I went and got my bachelor's and master's at WT, and I got my PhD at College Station. So I'm an alumni and a professor. So I teach environmental science. So I look at all the tools in the toolbox and try to figure out how we can go forward. Again, let's see if I can figure out which button here to push. Oh, yeah. So something I was talking, if you're unencumbered by facts, science, and numbers, then anything is possible. In other words, anything, you come up with all these great ideas, but if the numbers don't support it, if there's not a market there's not a financial incentive, it's not going to work. And I find this all the time. Is climate change really that complex, or are we allowing ourselves to become distracted? And let's look with my interview with the New York Times. I just had this. Interview with New York Times editor Henry Fountain, concerned with cattle methane production and global warming, worried about how cattle belching methane gas. They produce a lot of methane gas. Solution, let's stop eating beef, less methane. The vegans are very happy. I'm not against vegans, it's just the vegans are very happy because now it's taken on a political stance. You could feed 10 humans the amount of corn it takes to produce the equivalent amount of food value. So let's just convert all rangeland into grain production. Simple solution. But you're unencumbered by what? Facts, science, and mathematics. And so the bottom line is, agriculture only produces about 99.3% of all U.S. greenhouse gases, but produces nearly 100% of our food and exports that excess food to other countries less fortunate. So that's very important. And so what happens is worldwide agriculture produces about 17% of greenhouse gases due mostly to reliance on grazing for food on non-tillable lands. Less than 10% of the global landmass is suitable for and being used for agriculture, and of that only 2.3% is cropland and the other 7.8% is grazing land. Here's the issue, is that a lot of that land, you can't just convert it to cropland. It's not suitable for cropland. And if you look at that, many countries that don't have a lot of cropland are dependent on that. And so then are we even concerned about cattle, because aren't they part of the natural carbon cycle? What got us into this situation? Mining basically fossil fuels, nitrogen and the compounds, and putting it in the atmosphere faster than the natural carbon cycle can handle those materials. So why are we worried about cattle belching when they're part of the methane carbon cycle? Make it very simple. All right. So, so they depend on it. Grazing provides about 37% of global protein supply, so not eating meat and dairy is not an option considering the current 7.8 billion mouths to feed and the expected 28% increase by 2057, or to about maybe 10 billion. Now those numbers differ depending on, so these are some issues we're looking at. If we use pre-fossil fuel greenhouse levels as a baseline, current agriculture is only a small contributor to current greenhouse issue. In research by Rick Todd and the USDA team, methane produced by 37 million buffalo pre-fossil fuel was just about pretty much the same as the 30 million cattle we have today in the high plains. A concentrated feeding operation, which the New York Times was interested in, is actually about 2 to 3 times more efficient than rangeland feeding because they use less energy, and they basically, finishing at these feedlots, produce about 50% of our meat, which you may not realize, within a 100-mile radius of Amarillo, we feed 40% of all the beef in the United States. Very important to us. All right, now, the gain comes from land that for the most part is not suitable for crop production. So what happens is you have cow-calf operations on rangeland, and then those cattle go to a concentrated feeding operation for rapid weight gain for the meat market. Okay. And so here's the whole deal. This shows you the bison, wild ruminant bison, and you'll see Great Plains grazing cattle just about the same. So that's really not a concern because that's not adding anything to our carbon budget. So, while cattle production produces a large amount of C4, methane, those levels are very close to pre-fossil fuel times, so it's not contributing to the current greenhouse problem based on nutrient cycling. We do lack greenhouse gas baseline for agriculture, the starting point. Looking at the relative contributions of greenhouse gas from agriculture and current and proposed efficiency steps, I estimate that we could easily reduce U.S. greenhouse gas levels by 37% over pre-fossil fuel periods, just by managing the way we crop and do that work. The cost of sequestering Now we're going to talk a little bit. There's two things happening. One is we're sequestering carbon. Dr. Crosman talked about putting that in deep formations. There's issues with that. But what could agriculture do? So I look at the cost of sequestering carbon. It's roughly about $140 to $200 per ton. So agriculture's contribution to greenhouse gas reductions at 37% would have a value of about $8.2 to $11.8 trillion. There's a $1 trillion market that we're not exploring in agriculture right now. Okay? Fountain worries about manure management and wondered why CAFOs don't harvest C4. I discussed the difference between swine and dairy operations and our most pressing problem of water conservation and supply. We just don't have enough water. Also, reduced methane levels in anaerobic versus aerobic. Now we have NOx issues if we start managing that. So NOx, nitrous oxides, have a forcing factor. They're 300 times more of effect than carbon dioxide. So we're jumping from the frying pan into the fire on this system. Now, I explained that manure application and management reduces not only C4 and NOx releases, but also reduces the need for synthetic fertilizers, which was a mine addition to the atmosphere. So it's part of what? The natural carbon cycle. Okay. Now, Mr. Fountain's subsequent article focused on Bushland's research to reduce methane production by altering cattle feed. It didn't solve the problem, but that wasn't part of the storyline. Very frustrating to me, very frustrating to you, because we're not looking at the science, the facts, and the math. We're just looking at what is our storyline. Very frustrating. So, we as agriculture need to view greenhouse gas challenge as an opportunity to help global environment and ourselves and our bottom line. Establish pre-fossil. So what do we need to do? We need to establish a good pre-fossil fuel carbon baseline, because everything else from that will be something that we can market at some point in time. Okay, we're getting back to the marketing now. Okay, encourage both national and international incentives and rewards to ag for attaining net negative greenhouse gas contributions based on pre-fossil fuel baseline. In essence, we develop an ag cap and trade model. Pre-fossil fuel levels would be the cap, and anything below the cap would receive some form of compensation or credit. And I know that cap and trade is not popular, but it works. It works. And we used cap and trade in the United States for the first time. It's been supported by the international community as a way to address climate change, carbon and nitrous oxides and those depositions. So it works. It works. Now, a lot of people say, cap and trade. I save 100 tons here, and I sell it to someone over here for their 100 tons so they can put a new industry in. In other words, well, that's not the way it works. What they don't understand is how cap and trade works. The way cap and trade works, if I save 100 tons of carbon dioxide or nitrous oxide, what happens is you take your reduction off of the trade. So if you want a 20% reduction, you save 100, but you can sell 80. You've got your benefit, not in the future, up front. It works. It works. Okay, now, so conclusion. So what we need is a better accounting model and political support resolve. Pre-fossil fuel baseline is essential, as is the accounting model. So if we look at this, I want to look at right now, I want you to remember this. This is our basic U.S. primary energy consumption by energy resources. Now, if we look at all this, we look geothermal, solar, hydroelectric, wind, biomass, waste, biofuels, wood. We look at all of these contributions, natural gas, petroleum. I will tell you that James Henson, a climatologist and somebody that's been worried about this issue, said if we could just get back to 1965 levels, we as the United States would be doing our job. For the last 5 to 6 years, we've been there. So it's not all, I don't want to be Dr. Doom, but it's all, we did it. How did we do that? How did we do that? We shifted from coal to natural gas. Natural gas produces about half the carbon footprint of coal. That's how we got there. Now, so look at this addition right here, back to the math. Let's look at the production, and you look at where our energy's coming. Renewables, the green, nuclear, NGLPL, crude oil, natural gas, coal. Okay, So if we look at all those, you see the bottom line is natural gas is a huge supplier of our energy. Let's look at relative contribution of different agricultural sources to global anthropogenic emissions in percent. Look at fertilizers. We're going to talk about that in just a little bit. Fertilizers. Not a lot on global farming, but the bottom line is it has a forcing factor of 300-fold. 300-fold more impacting than carbon dioxide. So, and it's low-hanging fruit. Then let's look at manure, not much. Let's 29%. Basically looking at irrigation. That's going to be right now in the Texas Panhandle. What are we doing? We have right now planned decline. We're going to be out of water at some point in time. That bothers me a little bit about how do we feed that 10.5 billion people in the future. Dr. Crosman talked about one thing that concerns me is with you sea level rise. Everybody said, well, we'll just farm the East Coast. There's no soil there. All the mollisols and all the rangeland soils would be inundated. And you can't. They've tried to, if you look at the Appalachians, they make moonshine, but what? They get the corn from what? The plains. There's no agricultural land there. How did they make a living? Coal mining. So then how do you transition that culture, that group of people to other jobs, and what can you do with them? So there's some real challenges here. Greenhouse gas emissions, crop cultivation, livestock, fuel consumption. That's just for the irrigation and for the crops to harvest those crops. And you can see bottom line is that we're looking at basically emissions in millions of metric tons per year. So the total energy 2013, when we looked at that, we are going to produce about 93.59 quadrillion BTUs. That's what we're going to use. Let's talk about that. I'm optimistic. Let's look at the numbers. In 1970, after the oil embargo, critical fuel sources, the Ford Foundation assembled a blue ribbon team of experts covering all disciplines to write a plan. It was entitled A Time to Choose Energy's Energy Future, to assure that America would have enough fuel to get us to the year 2000, just to 2000. All right. In their plan, they estimated that 1970 energy use was 70 quadrillion BTUs per year and would grow to 100 quadrillion or quads by the year 2000. With their technical fix, if implemented, they estimated that energy use by 2000 would be 124 quadrillion BTUs, and with impacts of the gross national product and significant cut in services. The zero energy growth scenario baseline would result in what they thought was an unattainable goal and would result in 100 quadrillion BTUs by the year 2000. This is their projection. Now, this was 1970. Now, many of you weren't around then, but I can remember people pushing their cars to the gas station because they could only get 2 to 3 gallons of gas, and they burned more gas than they're idling, so people were actually pushing their cars up to get gasoline. This was after the OPEC. I remember when I was in first year of college, a friend said, you know what, gasoline is going to be $1 a gallon by the end of the year. I said, oh, that's impossible. Now, I remember gas wars when I was a kid, and they said gas was like 15 cents a gallon, 18 cents a gallon. There were signs out there, you pay the tax, we'll give you the gas. And I thought that would never happen. Within a year, gas prices were over $2. It went up that dramatically. Now, so if you look at this historic growth, if we just stay doing what we're doing, we're at about 70 quads. We're going to go up to about 100, over 175. The technical fix was 125. The zero growth, now you have growth that you can't just stop, and so that would be about 100. It's 1970. In 2013, we were at 93.59 quads. How did we do it? We exceeded their greatest expectations. And how did we do that? We did that with what? Clean Air Act, a big part of it. How do you regulate something like that? How do you regulate the emissions? Stationary sources, mobile sources. Start regulating those sources. Mobile emission and gasoline use regulations, cap and trade, that was first used for the conversion from leaded fuel to unleaded fuel. The first time they did that. And then they applied that to what? Sulfur emissions and in the Clean Air Act. It works, it works. Public support, market demands and expectations. So here's something. I think it's agriculture. We could take care, if we took care of 37% of our carbon emissions, we would be what? Well, we're already at 1960 levels, but we could really go below that market. And I think we're missing a major market. So Farmer X produces a grain crop that uses 10 tons of mined fertilizer per acre. That's a conservative application rate. Nitrogen has a 300x forcing factor over CO2. Farmer X switches to legume production, and those are nitrogen fixers. They don't need fertilizer. They produce their own fertilizer, and guess how they get it? They take nitrogen out of the atmosphere. So that's a win-win. And what he has, he's already got a baseline. He knows how much mined fertilizer he put on in the previous 10 years and years. He said, if I just stop doing that and I start growing legumes or nitrogen producers, or let's say I do a crop rotation where I grow legumes, nitrogen fixers, to condition the soil, and then for 2 years I grow other crops that we might need, like wheat or corn. We do that. So that's where we go. So we grow beans, peas, lentils, chickpeas. A 100-gram serving of cooked chickpeas contains 18% of the daily value for protein, 30% for dietary fiber, and 43% for folate, and 95% of our manganese that we need. Farmer X receives credit and payment for nitrogen avoided, as well as calculated nitrogen removal in cap and trade scenario as well, and that can be sold on the futures market. Payments offset cost of retooling from traditional crops to new products. Marketing to change public perception and to develop new markets. How many of you have eaten lentils or chickpeas? So that's a marketing issue. Can we develop a market to do that? Okay. Change feedstock for CAFOs. Don't think it really makes that much difference, basically to improve crop rotation legumes, prep soil for and a rotational crop. No need for synthetic mined fertilizer, just done. Not mining that material at that point in time. So the team, how do we get this done? How do we do this? Well, we need scientists, agriculture, business, marketing, public involvement, political resolve and support, and what we call aspirational regulations. That's what they did in the Clean Air Act. You stop and think about it, our nitrous oxide levels in the atmosphere are basically the same as they were in 1970. If somebody would have told me what they did is they said they end up with CAFE or car fleet gas mileage regulations. And that's what we call an aspirational regulation. This takes political and public resolve and marketing to get this done. And what they basically said was, you know, you're going to have an average car fleet gas mileage of your car fleet 21.3 miles per gallon by 2000. A lot of the auto companies said, you know, we're not going to do that. It's impossible. By the way, the average car fuel consumption at that point in time was about 10.5 miles per gallon. They were gas guzzlers, okay, big heavy cars. And a lot of the industry said, you know, we're not going to do that. But then Chevrolet thought, but you know what? If Ford does it, they're going to have 100% of what? The car market. So they all started working on that. And if somebody would have told me back in 1974, my GTO at that point in time made about 9 miles per gallon, that there would be a Cadillac that had over 300 horsepower and made over 30 miles per gallon in the future, I would have thought they were. So we tripled the car fleet on the road. We kept the nitrous oxides level. So can we do it? I think we can do it, but it's going to take political resolve. Talking about carbon capture, I'm meeting in New Orleans on Saturday for an environmental forum, and they're concerned about carbon sequestration, deep carbon sequestration. The public is concerned about what does this do to our groundwater? What they're going to do is take liquid carbon dioxide, pump it into basically retired oil formations, and sequester that carbon. There's a cost to that. But the public are concerned. It's going to affect our groundwater. One of our students, by the way, Josh Brownlow, was in a meeting. He's a geologist, and he's basically in charge of a huge, huge carbon sequestration project. And what he needs now is we need to market that concept to make it basically appealing to people. They're saying, if you sequester over there, is it going to come on my property? What's it going to do to my groundwater? He said, well, it's just like CO2, like you have in a soda. And said, oh, you're going to convert all of our water into soda now. And so there's a public program that has to be, and the science look at it. But I'm optimistic, but it's going to take basically political resolve, which is based on what public resolve, to get this done and to march into the future. So I like to use this article about the Ford Foundation. It shows what we can do if we put our mind to it. And so I'm optimistic. I think it's a challenge. It's a challenge that you all will have, and I think you're going to find out this is not a simple project. It is one that's going to take an integrated team. And you can come up with the best product in the world, but if you can't market it, it's not going to help you.
Okay, so you talked about the climate change of the rain, right? So this whole entire, I want to say, month, there's been a lot of wind. How is that affecting us in the future as well? Because there's going to be drought, so what is that going to do in the future?
Yeah, I meant to mention, I'll start. I meant to mention that we're going in with, call them flash droughts or flash floods, right? It's also a flash drought. We're going to go into drought more quickly with hotter temperatures. So all else being equal, we'll dry out more quickly if the temperatures are warmer. I'm from New Mexico, and the pinon trees are dying because they're adapted for long droughts, but not at the temperatures they have. And people have done greenhouse experiments where they ramp the temperatures up by 5 degrees with the same amount of water, and they die. And so they're just not, they're adapted to really long dry periods, but not to really long hot dry periods. So our grasses, and I think here the main concern is just crops, right? I mean, we just think we can water so much, but if it just be the heat stress that we're going to, in 2011, we lost half the crops. So I would that's just concerning. I think the cattle industry, there's a slide I didn't show at the end as far as if you get genetic variations of the cattle that are really tough to heat, and then do some mitigation, have some shade, like some evaporative spraying to cool them or whatever, we could probably have them here even in extreme heat, and then ship the grass in from Canada. So
one thing I think is very important is that as we're managing depletion, the Ogallala is going dry, is that we have a program in place where we use some water to reestablish the grassland that was there rather than just leaving barren soil. And so I think that's going to be, a lot of the projects we have, the big water projects have not been done. Those are going to be done in the future. So it's going to be undoing a lot of the things that we've done. So what we need to do, those grasses that we have now are established back during wetter periods. It's going to be drier. They're going to need to have some additional water to get those reestablished, and then plant those grasses that can tolerate low water conditions. I think it's going to be very, very important. That's going to be a massive program. To give you an example of another massive program, there's a proposal right now, Lake Powell, Lake Mead, okay? They're running out of water, okay? And it's not so much what's leaving the dam, it's not getting there. Center pivot irrigation changed the water balance incredibly, because people thought that the soil scientists didn't think that a lot of those soils were irrigatable, but with center pivots we can. So now we don't have as much water going in. There's a proposal now to drain Lake Powell into Lake Mead. Lake Mead could take all the water in Lake Powell without increasing its surface area. And if they have an evapotranspiration rate of about 10 feet per year, that would save thousands and thousands of gallons of water. But it's a huge marketing, it's a huge social, economic, social problem in abandoning those projects. And how do you restore those people that invested a lot of money in those programs? So it's a huge challenge for you.
Dr. Almas?
First of all, I really appreciate that, excellent presentation, both of you professors. My question is twofold. Number one is, it's a very significant issue that we have droughts and we have floods. So what we can do to manage that water during the wet years? It needs a lot of investment to have dams or whatever, the lakes you have mentioned. So how we can utilize that natural water, because this area is already water deficit. My second question is how we are going to, because it's a very significant issue, climate change and food production and population, more than 10 billion as projected. The US will be the third largest country by 2050. So how we are going to feed our population when we are, as US is out of the international climate agreement? Thank you.
If we could find some ways to pool and like playa lakes that, find ways to get that water, because we evaporate 10 meters a year right? Like we have such high evaporation rates. So if we could find ways to take, when we have the 10 inches of rain, in a short amount of time, so I certainly think that we will have a similar, a little more rainfall, but it's going to come and evaporate even more quickly and be even more unpredictable. So finding ways to have dredge channels that are deep because it'll just evaporate from a surface. To me, we have to find ways to get it into the ground.
One thing we're working on now is using produced oil field water for salt gradient ponds. Salt gradient generates electricity, which we can use for desalinization of marginal waters. So we have a lot of Santa Rosa water that's almost, and we're not going to desalinize, that oil field brine is about 15.8% salt. We can make salt gradient ponds and use solar energy for those ponds. And then, oh, by the way, as far as we're injecting that heated solution into deep formations, and then we use that energy to produce drinkable water. And that's another thing we're working on. Now, that's a very expensive process. The pilot is going to be $100 million. That's where the resolve comes in.
And as far as back to your second question, I honestly don't know. I mean, I know there's ongoing research. I mean, you probably may know some aspects of that answer better than me, seeing what our thought on it was. I mean, I have no doubt that our region, however it pans out, will continue to be a huge producer of food for the world. But I mean, beyond just like adapting and shifting some of the operations, I don't know the feasibility of like if we have a 130-degree heat wave, I am concerned about, and like a really bad wildfire outbreak, we're going to have to, but maybe there'll be fire lines and everything's more set up so that we've taken a step ahead of time to prepare for those. One
of the problems we have is that when we have these extended drought, we lose the grass dries up and breaks off and exposes the ground, and then we can get soil temperatures up that basically will sterilize the seed bed that's there. So in the last few years, we've seen situations where natural reseeding is not occurring. We have to reseed the areas because basically sterilize the soil. So those are all concerns we have.
I think we are out of time, but just concluding comments. Every slide Dr. Crosman showed and Dr. Rogers, it applies to marketing. $44 trillion, as I mentioned, my data, it's a global market. We are all in this situation together. It doesn't matter if you live in Pakistan or India or Germany or Greenland or anywhere. If you take the example of Pakistan, glaciers are melting and melting big time. If you take the example of some of the islands, they are submerging. I was reading that data yesterday. In the next 80 years, some of the islands in the South Pacific may not be there, in the Indian Ocean. So basically, as you correctly mentioned, it needs some cooperation. And when human beings are not all that good in cooperation, sometimes, we have our vested interests, but it was a wonderful talk. I wish we had more time, but someday we will invite them again and we will have another topic. This topic is not going anywhere. It's going to be here, and marketing is part of it, business is part of it, agriculture is part of it, sciences are part of it, and it's on the radar screen almost 24 hours a day. But thank you so much, and we appreciate our speakers, and let's give a hand to our speakers.
Thank you.